This is my attempt at answering a question that I've heard over the years many times. We get into some hard stuff in algebra, and somebody's like, when are we ever going to need this in the real world? Or, who invented this stuff anyway? Like they want to be mad at somebody for it. First of all, I can give you the sarcastic answer. Well, in your real world, you're going to need this stuff next Tuesday on that quiz. Or I might say, as much as I like you teenagers, you got to admit, some of you can be dangerous to yourself and to other people. So we invented algebra to keep you busy, to protect you from yourself. Okay, you guys get too much time on your hands, you start doing some stupid stuff. You like skateboard off of rooftops or something just to see what it feels like. Start getting into more cyberbullying than what you do. You might even end up doing drugs. So, hey, algebra's there to keep you in this room working and thinking and concentrating on something else other than stupid stuff. So eventually I get around to being more serious about the right answer to this question. And I will usually start by saying, well, nobody invented this stuff. We discovered it. Really, just like nobody invented chemistry. Okay, those elements were there. People described it and discovered it. And when it comes to like, how are you going to use this in the real world? Well, let me just say, there are things you can't do unless you understand this stuff. My main reason for you learning this stuff is because I really want you to understand the world you live in. It's really why we do school. We teach history because who we are as a country, as a people, comes from somewhere. It's taken a long time for us to get here. The more you understand that, just the more you understand the world you're in. Okay? Understanding chemistry might make you understand why water freezes, might make you understand cheese melting. It just helps you understand the world you're in. Algebra does the same thing. Not only that, it helps you predict things. I'll give you some examples. You earn money, $8 an hour, $10 an hour, whatever. Algebra can describe how much you're earning over time, okay, and how much you'd have if you keep this at a certain pace. You can see how much you'll have because of a simple linear equation. Linear equation means it's a straight line going up, okay, at your dollar per hour rate. How fast you go over time, okay, you average a certain speed. You average a certain number of points in a sport. You can graph that with a line. If you lose something at a certain rate, lose weight over time, for example, it goes down in a line and you can sort of predict out where you'd be in 6 months if you continue at that pace. Then there's other things that don't grow in straight lines. An exponential equation describes something that actually grows more over time on itself. For example, like rabbits, okay? They're known for growing quickly. And so when those babies start having babies, it went from like 2 to 4 to not just like 5 and 6, but like to 8 and to 16, and it grows more quickly on itself. The coronavirus right now is a really good example of that because especially at the beginning, you could see how quickly it grew. So it did not grow in a linear direction. It grew the more cases that were there, the more it spread, the more quickly it spread. That is an exponential equation, which means the variable is up in the exponent. Okay? Something to the x power ends up being the same type of graph, the same shape. It's so practical because how much money you earn if you invest in something is also exponential. Okay? Hopefully exponential growth and not exponential decay, going down and losing. It grows over time. If you can earn 5% interest, your money can double in 13 years. Okay? An exponential equation shows you that. So it helps you understand and helps you be wise about the future because you can see the future. A whole different type of equation is a curve that's not going up forever and ever, but it's a curve that looks like this. Okay? And if you look at every one of the paths of these balls, they're all the same shape. Some go a little higher, okay? Maybe they go a little lower, but it's the same exact shape. It's a curve that's called a parabola, but it can be graphed using an x squared equation. If I drop this, looks to me like it goes straight down, but the graph of the height doesn't go straight down, and you all know that. Because if I say jump off that desk, you'd be like, why? But you wouldn't be afraid of jumping off a desk. But if I say jump out that window and we're on the second floor, you wouldn't do it. And you would say that would be stupid. Well, that's because you understand that something happens over time to the height of the ball. It's dropping, but somehow it speeds up. And so when it hits the ground, it's going a lot faster than if it drops off the table. The height of the ball over time is a quadratic equation. It's not going down at the same rate. The sound you're hearing right now comes to you from in a different algebra equation. It's a sine curve, and that is an equation, an algebra equation, and it's a wave. It's coming to you and hitting your ear, and I could stretch that out with an equation. If I stretched it out, it could get louder and quieter, or it could get higher pitched or lower pitched depending on how the graph is. Just trying to give you some examples of how algebra describes real world kinds of things. And the more you know that stuff, the more you'll understand the world you live in. Nice side effect, you'll have less time to do drugs.